Hey there, sixth graders. We're going to go ahead and take a look at some more complicated proportions that are going to involve the use of the distributive property. So the good news is we already have the skills to be able to solve these types of nastier proportions, and I think you're going to be pleasantly surprised at how easy it ends up being. So remember, we do indeed have two methods to solve proportions. We have equivalent fraction route, and we also have that new process that we studied earlier this unit called the cross product. And we might find that the cross product is going to be really useful in this case. So sometimes our variable it's not just sitting alone, it's actually being added or subtracted within our proportions. And in this case, and I shouldn't say we need to use, there are actually other ways to do it, but I do think, in my opinion, it's usually easiest to use the cross product in that case. And what we're going to find is that we actually need to use the distributive property to complete the cross product. So let's go ahead and oh, sorry, I'm getting ahead of myself. So after you've used that cross product, you're actually going to have a two-step equation. And remember, we're going to use SADMEP, the reverse order of operations, to undo the numbers that are cramping the variable style. So we still want to get x all by itself, or the variable all by itself. So for instance, if we look at this first one, we have 4 and 6, which are not super compatible. I can't turn 4 into 6 using my equivalent fraction skills at the moment, so I'm going to go ahead and use the cross product on this problem. Now, here we have two numbers, which is really nice and easy, so 6 times 6 is going to be on that side. But now when I take a look, I actually need to multiply 4 by this entire bottom piece right here, by this whole thing. So I'm actually going to use parentheses to make sure that I do indeed multiply the 4 by this whole thing. Now remember, a big fraction bar like that is a grouping symbol. So we need to make sure we put parentheses around both of those. So now we have now we have 36 is equal to, and I'm going to go ahead and use the distributive property, multiply in, and I get 4x plus 8, and now I have a nice two-step equation on my hands. So now I'm going to use SADMEP. I'm going to get rid of addition and subtraction first. I'm going to subtract 8 from both sides, and I get 28 equals 4x. I'm going to divide both sides by 4, and I get 7 equals x. Now we can check our work. That's the beauty of algebra, is we can check our work. We can check by plugging back into the original equation. So my question is 6 over 7 plus 2, that's a plus, sorry, is that equal to 4/6? Well, 6 over 9, we need to know, is that equal to 4/6? Well, I think I can simplify both of these. If I divide these two by 3, I get 2/3. And actually, if I divide both of these by 2, I also get 2/3. So I have that 2/3 is equal to 2/3, which is the true statement. Let's look at the next one. So we have 4 and 12, and these actually are compatible. So I know that I would be multiplying this by 3 to get me to 12, which means I need to multiply this by 3 to get me this whole thing. So if I multiply this whole top thing by 3, I know it needs to equal the 3. Or excuse me, I know that 3 times 3 is going to be 9. So I know this, I need this top portion to be equal to 9, because if this were just a single letter alone, if this was just y would be equal to 9, because 9/12 is indeed equal to 3/4. So what I'm going to do here is I'm going to skip some steps, and I'm just going to go ahead and set 9 equal to this entire top part, y minus 3. Now this is actually just a one-step equation because I only have one operation. So I'm going to go ahead and get rid of the minus 3 by adding 3 to both sides. And I get that y equals 12. So if I were to check this, is it true that 12 minus 3, which gives you 9, is it true that 9/12 is indeed equivalent to 3/4? Yes, it is. Now, if that didn't make a ton of sense to you, the good news is we can still use the cross product on this problem. So let's solve it using the cross product as well. So I'm going to go ahead and multiply my opposites. So this is going to be 12 times 3 is equivalent to 4 times this entire thing. So you got to make sure you use your parentheses. 4 times y minus 3. We can go ahead and start solving. So that's going to be 36 is equal to 4 times y minus 3. Now I want to remind you, this is a grouping problem because I have parentheses. Now over here, I use distributive property. I'm going to use that other method where I divide first so that I'm undoing parentheses last because p comes last in SADMEP. So we're going to go ahead, I'm going to divide both sides by 4, and this ends up being an easier problem. 9 equals y minus 3. Now notice, that's the same exact equation that we started off with by using our equivalent fraction route. So I think equivalent fraction route saves you a little bit of work. Well, obviously it does save you work, but it can be a little difficult to think abstractly and understand what this needs to be equivalent to. So please know that the cross product is a perfectly valid option for you. So again, I add 3 to both sides, and in either case, we still get that y equals 12. Let's do a couple more together. I'll do both options for you on this next one because it does appear that we can use equivalent fraction route. So I can turn 7 into 14 by multiplying by 2. So I'm going to go ahead and do that to the top. And that tells me that this p plus 5 will need to be equal to 8 so that I have equivalent fractions. So I can go ahead and just right away set p plus 5 equal to 8 because I know that whole numerator will need to be equal to 8 because of equivalent fraction route. So we can go ahead and subtract 5 from both sides, and we get p equals 3. Let's go ahead and use the cross product and see if we do indeed get the same answer, which we should. So if you prefer the cross product, which is totally fine, we would get 4 times 14. If I multiply these diagonals, is going to be equal to 7 times that entire numerator, p plus 5. So that's going to be 40 plus 16 is 56 is equal to 7 times p plus 5. I'm going to go ahead and divide both sides by 7 first to save parentheses for last. We get 8 equals p plus 5. Again, I want you to notice we have the same exact equation as we did from using equivalent fraction route. This is a little bit more work, but it will ultimately get you to the same final answer. And we get that p is also equal to 3. Now let's take a look at this next one. Unfortunately, equivalent fraction route is not an option for us here because I can't turn 2 into 9 nicely. So I'm going to go ahead and go straight for the cross product right off the bat. So I'm going to go ahead and multiply my opposites. So it's going to be 27 is equal to 2 times, remember I have to multiply it by the entire denominator, so I'm going to use parentheses, 2 times y minus 2. You can go ahead and distribute if you'd like to. You have 2 options. You can divide by 2 first if you'd like to. Either way, you'll get to the same final answer. I'm going to add 4 to both sides. I get 31 equals 2y, divide by, 2. Divide by 2, and I get y equals 15 and a half. So again, you already have all of these skills. We know about distributive property. We've already learned about the cross product. We already know about equivalent fraction route. So we're just taking all of these things that we already know and we're blending them together to solve more interesting problems such as these. So go ahead, try the backside on your own and check the website for the answer key.